In 2 meters, turn left.
What?
I have detected that you have entered another country.
What?
Would you like to change the language to
Klingon.
What? Where am I?
Well, aloha, everyone. Today we want to talk about the answer to that question. Where am I? Where is anything, honestly? What we want to do today is we want to develop a scientific way of answering those two questions. So, what do we want to talk about today? We want to talk about position. We want to talk about distance. That's a C. And we want to talk about displacement. And with those three things, there's no better way to learn about wonderful things like that than to play a little Minecraft. Alright, here we are. Brand new world. Looks like we spawned in Taiga, maybe. So I'm going to start off by marking the block that I'm standing on. I'm going to put down a piece of red sand right there so that I know that that's exactly where I spawned from. Why? Because this is going to be what I'm going to call my origin. Yeah, I know how Minecraft has built-in systems for this, but I'm going to call this my origin, so my position here is going to be 0. Now, I also need to think about directions. You'll notice in your math class, usually they call positive to the right. But in this case, I don't think we're going to call positive to the right. We're just going to pick a direction, it really doesn't matter, and call it positive. So I'm going to call that way positive. So I started here. I'm going this way. Maybe I'll make an arrow, something like this. Okay, there we go. Pretend that's an arrow. And so I'm going to call that way positive. So if I move this way, I would be said to have positive position. If I was to move past the origin back this way, my position would end up being negative. Now here in Minecraft, most things are measured in blocks. And blocks are supposed to be 1 meter on any side. So I'm going to measure, I'm going to walk this way, 1, 2, 3, 4 blocks to the end of this. So I have now walked in the positive direction, a distance of 4 meters. So my position here would be positive 4 meters. If I go back here, my position is back to 0. If I go over here, 1, 2, kind of have to get up here, 3, and 4. Okay, so if I'm standing right here on this block, I am now 4 meters in the other direction. I'm not in the positive direction, so my position here would be negative 4 meters. Now that having been said, you'll notice that in Minecraft, you can't just move this way, forward and backward. You can also move side to side. I can go this way, and I can go back this way. So because of that, I need to call another direction positive. I need to decide which one I want to call positive, either that way or that way. It really doesn't matter, I just need to pick something. So I'm going to call this way positive also. Oops. And I'll make an arrow kind of here to tell you that this way is positive as well. Okay, so now this is 0, 0, but I need to call one of these directions X and one of these directions Y. Now, in your math class, usually they would look at your coordinate system like this and say to the right is X and up is Y. But it really doesn't matter. If I wanted to, I could call that way X and I could call that way Y. And that would work just as easily. But it turns out I'm just going to stick with what they tend to do in math class. I'm going to call to the right from this perspective positive X. And I'm going to call upward positive y from this perspective. So that means now I can determine where I am anywhere on this map. If I go running around, I can just measure from the origin. How far am I? My position is determined by, well, if I started here, here is 0. Let's say I walk this way, 1, 2, 3, 4, 5, 6. And then I walk this way, 1, 2, 3, 4, 5, 6, 7. Let's call it 8. So if I end up on this block right here, I have gone, yeah, that tree's kind of in the way. But I have gone 8 blocks in the y direction, and I've gone, what was it, 6 blocks in the x direction. So this would be a coordinate. My position would be determined by a coordinate of 6, 8. Okay, so that tells you about position. If I went on the other side, I could probably have like, I don't know, over here I might be -6, -3, something like that. If I went way, well, yeah, if I went way over here but stayed pretty much in line, I might be 0, -20, something like that. So it's really just like the coordinates on a graph. But there's one more coordinate we need to be careful of. In this game and in real life, you can move left and right, you can move forward and backward, and you can move up and down. So because of that, we need to choose one of those ways to be a coordinate as well. So I'm going to call positive upward. So this direction is going to be positive. So now I can tell where I am in any of the 3 dimensions by looking at how far I am in the origin in each direction. And instead of an ordered pair, I'm going to have an ordered triple. So if I was over here, I would be, I don't know, positive, looks like about 15 maybe, positive 10 maybe, and finally my z coordinate would be positive, looks like I went up about, I don't know, 10 blocks or so. Something like that. We could measure very carefully. If I was to go back over here, I'd have a negative x coordinate, a negative y coordinate, but a positive z coordinate. And if I was to go somewhere over here, but then decide I want to go down into the ground, now I would end up having positive x, positive y, and negative z coordinates. The next concept that's important that you need to know about is called distance. And we're going to learn the difference between distance and something we call displacement. So let's talk about distance first. I don't want to get my z direction involved here, so I'm going to be building up a little bit here of this sand in order to keep from going up and down too much. But okay, so let's say I start at my origin. I go 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks, 6 blocks, 7 blocks, 8. That's probably good enough. 8 blocks. So I went 8 blocks this way. The distance I have traveled is 8 blocks, or 8 meters if this was real life. When I run back over here, I have now gone a distance of 16 meters because I went 8 that way, and then I came back 8 blocks. If I go back this way, I've now gone 24 blocks, and then if I run back this way, I'm now at a distance of 32 blocks. That's pretty straightforward. In 2 dimensions, it gets a little bit trickier, because if I go this way 8 blocks, and then I go this way, I don't know, 1, 2, 3, 4, 5, 6, 7 blocks maybe? So I've gone 8 blocks that way, and 7 blocks this way. My distance I have traveled is 15 blocks. Pretty easy, right? You just have to add the 2 distances. So distance keeps on adding. Distance can't be negative. If I run over here, I still have a positive distance I've traveled. You can never have a negative distance. Distance is what we call a scalar, which means it doesn't matter what direction you go in. I can go this way and then go this way. I just keep adding the numbers together. So as I run around, the distance I have traveled keeps on getting bigger and bigger and bigger. The distance I've traveled never goes down, even though I go back and forth, and even though my position might end up back at the origin here, where my position would be 0 again. So let's talk about displacement then. Displacement is going to have two parts. It's a vector. What do I mean by a vector? Well, it's a special type of measurement. And that special type of measurement is going to have two things to it. It's going to have a magnitude, which is really just a number that measures how big or how strong something is. And it's going to have a direction. So, if I run this way 8 blocks, my displacement is 8 blocks in the, I think we called that the x direction? Yeah, that's the x direction. So I've gone 8 blocks in the x direction. Maybe you could call it 8 blocks to the right. Maybe you could call it 8 blocks, I don't know which way that is. If that was east, that's to the south. That would work as well. Okay? But displacement is also a measurement of from where you started to where you ended. It doesn't care about how you got there. It only cares about how far is it from your original point. So if I run back here to the origin, now my displacement is going to be 0. Why? Because I'm back where I started. If I run back over here, my distance I've traveled now, I've done this 8 this way, 8 back that way, and 8 back this way. So my distance I've traveled is 24 meters. However, my displacement here is only 8 meters in the positive x direction. What if I add a second dimension to that? So I go 8 meters this way, and I go 1, 2, 3, 4, 5, 6 meters this way. So I'm now, well, let's not go up. Let's stay on the same level here. So now I've gone 8 meters this way and 6 meters this way. What is my displacement? Well, my displacement is the distance from where I started to where I ended along the shortest possible path. So it would be along a diagonal. So, well, kind of the tree is in the way. Let's move this tree out of the way. But it would be along a diagonal, kind of like this. So what would that displacement be? Well, I went 8 meters this way. I went 6 meters that way. So what would we do? We would use the Pythagorean theorem. That's a triangle, and we're trying to find the diagonal of the triangle. So let's take a look at what we learned from our Minecraft experience. We found that position ends up being a coordinate. If you only care about one dimension, it's probably going to be just a positive number, positive 3 meters, or maybe negative 2 meters, or something like that. If you have two dimensions you're looking at, it's probably going to be something like this, positive 3, negative 2. Or maybe you just might write that as 3, comma, negative 2. Something like that. And if you have 3 dimensions, x, y, and z, so that means x is going to be left and right, y is going to be forward and backward, and z is going to be up and down, you might have a coordinate that looks like that. Negative 3, 1, negative 2. And you can figure out exactly where something is if you know where that origin is. Distance, if you remember, is what we called a scalar, which means it's always positive, and it doesn't have a direction. So if you start here and you run this way, a distance of, I don't know, let's call it 10 meters, the distance you've traveled is 10 meters. If you then run back to where you started, you're going to have a total distance of 20 meters to go there and to go back. Okay, displacement, on the other hand, was what we called a vector. And it only cares about where you started where you ended, and the direction that you are in. So if you start here and you travel this way 10 meters, your displacement is now 10 meters as well. Over here, this was your distance. You'll notice I use an arrow over the D here. That reminds me that this thing has a direction, and that means that I need to put that direction down on my answer. So it's not just 10 meters, it's 10 meters in the positive direction, 10 meters to the right, something like that. You have to have some sort of indication of what direction you're going in. So this is 10 meters to the right. Okay, now if I was to do something where I started here, went this way 10 meters, and then I went back that way to where I started, 10 meters also, what would my displacement be? Well, my displacement in this case, if I ended up exactly where I started, the displacement will be 0 meters. And that one isn't gonna, we're not gonna put a direction on it because we could put east, west, left, right, up, down, and 0 is 0, so there's no big deal for a direction when it's 0. Anything else, you need to write a direction on it. So your displacement is 0 if you end up where you started, no matter how far you went. Now, it gets a little bit trickier when we start adding 2 or 3 dimensions. So for instance, if you start here and you travel this way and you travel that way, maybe you traveled 3 meters this way, maybe you traveled 4 meters this way. What is the distance you have traveled? Well, the total distance you have traveled is going to be 7 meters. Over here, let's say you travel this way 3 meters. Let's say you travel this way 4 meters. What is your displacement? Well, your displacement only cares about where you started and where you ended. So it's from where you started to where you ended, and in this direction. So your displacement is going to be, put the arrow over the D here to tell the difference between the two. Your displacement is going to be whatever the hypotenuse of that triangle is. In this case, it's 5 meters. And I need some way of indicating what direction this is. A lot of times you'll have to calculate this angle here, but we don't want to get into that too hard right now. So what we're going to do is we're just going to say, I don't know if it's to the right and up. I don't know, to the, I don't know, maybe I could do something like this, call this north, call that east, call that south, and call that west, in which case that direction is to the northwest, give or take. So the key pieces that you need to know. Position tells you where you are relative to the origin. It only is some coordinates. Imagine you're on a grid, and those coordinates tell you where you are. Distance only tracks how far you've gone. It keeps on going higher and higher and higher the farther you go. Even if you turn around and come back, your distance gets higher. Think about it as the odometer in the car. You drive the car, and it just goes up. Even if you turn the car around and come back, your mileage still goes up. Displacement tells you how far you are from where you started and in what direction. So, displacement, remember that, it's a vector, 2 pieces, how far you've gone, and in what direction. So really, that's about all there is to it for position, distance, and displacement. Mahalo for watching, and see you next time.